How's your Labor Day? Long weekend? Enjoying?
It was exciting.
But the weather was not very good. I went to other banks, but Saturday we didn't do anything. Yes. But it's really bad. So my wife refused to go out for dinner, so I just got some takeouts. But Sunday at 1, pretty good. Yeah, nothing to complain. Well. I hope you enjoy the Labor Day. Now I think the official beginning of the beginning of the fourth semester of this long weekend. Because I will post the homework in Blackboard very soon, probably today. And also you can begin to do your homework.
No rush.
No rush?
No rush to post it.
Sure, no
Take
rush.
your time.
But the due date is the same. I can
Oh.
2 days before the due date if you want.
Don't listen to Chad.
Post
Don't listen to Chad.
way before, right? Okay, so recall what we have learned last week before we travel to some place or be back home, right? So that's what we have learned, right? We have built the linear trend function based on the past 10 weeks sales data, right? We mentioned before, you remember, ideally we should use the past historical demand data. But we have discussed many situations where we only have sales data, and many situations, in most situations, sales is equal to demand when there's no stock outs. If we have enough inventory, sales equal to demand. So, as we use the past sales data to build our linear trend model and to make the forecast of week 11 and week 12. That's the linear trend. Here's the formula we use to capture slope B and intercepts A. Next model, I'll talk about forecasting. It's a little bit complex. It's called the trend adjusted exponential smoothing method. Well, before we go to study this model, I want to have a quick review on what we have learned, which is the exponential smoothing model. So for exponential smoothing model, it's pretty straightforward. The forecast is based on the previous forecast ft minus 1 plus a parameter, usually it's between 0 and 1, or you can think about it as a weight, alpha, times the forecast error. I keep writing something wrong. At minus 1 minus ft minus 1. So this is the exponential smoothing model. I hope you still remember that, what we have learned last week. Right? So this model use the last period forecast, ft minus 1, and last period's actual sales or demand to make the forecast for next period. So that's the general idea of this model. What we will learn now is a little bit the extension of this traditional exponential smoothing model. It's called trend adjusted exponential smoothing model. Okay, then let's look at this formula. So TAF is nothing, is trend adjusted forecast. Well, if you don't like this, you can still use FT plus 1. It's fine for me, right? But if you use TAF, you know that it's trend adjusted forecast, which means we should use this formula equal to ST plus TT. Well, ST is the previous forecast plus the smooth error. Let's see what is ST. So, ST is equal to TAFT plus alpha AT minus TFT. You can see the smoothing factor used for this trend adjusted exponential smoothing method. It's nothing but the same as the forecast of exponential smoothing method. Well, if you still are not so sure, I can change the notation a little bit. Okay. say this one, just make the symbol the same. Then you compare these two formulas. Look at them. This is the same one, right? Well, as I mentioned, you don't need to use the TAF. It's just a forecast, but TAF means trend adjust forecast. If you use FT, right? So FT here, it's the same, right? It's just the forecast plus alpha times the forecast error. Forecast times plus alpha times forecast error. So in this trend adjust exponential smoothing method, the first term ST in fact is nothing but the traditional exponential smoothing forecast, right? That's ST. Clear? It's clear for ST? Clear, right? The difference is just here. It can capture trend TT. Well, TT is the current trend estimate. So the traditional exponential smoothing we have discussed here is just a weighted average between your last period forecast and last period actual value, right? It has nothing to do with trend. Doesn't capture your trend. It's like naive method. Okay, you can use the pure naive. You can use naive with trend. This method will capture trend. The first term ST the same. Okay, just the weighted average. But the TT, which is the trend estimation, see, it's the TT, right? It's equal to the previous trend estimate plus another parameters, beta, forecast, minus previous period forecast, minus the previous period's trend parameter. So this is a little bit complex. Okay. So basically speaking, every period you have to adjust the trend estimation a little bit. How do you adjust that? It's based on your last period trend estimation, T, capital T, T minus 1, times the beta parameters, well, with the forecast change from period T minus 1 to period T, and also minus the last period trend adjust estimation. So that's the formula. So we don't have time to introduce an example in this class. Well, because if we introduce an example, that will take a very long time, right? We'll have a homework question cover this class. It's an example in the textbook. You should review that for sure. Well, homework will have questions, and from my experience, it can be one of the hardest questions in the homework. So if you do the homework for this trend adjust exponential smoothing method of questions, please let me know. Right? Definitely, I also encourage you to discuss with your classmates to try to figure out them. Right? Well, this part, we don't have time to go through an example. I can only explain this formula to you. You understand, right? The first part, ST, is nothing but the traditional exponential smoothing method. What's new for the trend adjust exponential smoothing method is this TT, trend estimation or trend parameter. Okay. Questions? It's good. All right. So next we'll talk about is a very important pattern for our forecast, seasonality. Well, we have discussed, right? There's so many products has very strong seasonality. Well, so we have to pay a lot of attention on seasonality if some products have this pattern. By definition, it's the regularly repeating movement, a series value that can be tied to recurring events. So the expression is that, okay, the actual value deviates from the average value of a series. Seasonality, we know that, right? So turkey, Christmas tree, candy, pumpkin, there are lots of things has very strong seasonality. That we know. But when we come to the forecast, we need to introduce some formal model to capture seasonality. Because different items have different types of seasonality. It's not so straightforward, right? There are two basic models we can use. The first one is additive model. So the additive model means, okay, your forecast, your demand in this high season or low season expressed as a quantity add or subtract from time series average, right? You have the average demand like turkey, right? We eat turkey, people still eat turkey every week, but during the Thanksgiving, right, the turkey demand is huge. So it's an added model, additive model. Another model is called a multiplicative model. So when you make the forecast of the seasonality like turkey, you don't add like 1,000 units, okay, from the like average demand. You multiply by 2, by 3, something like that. You say, okay, I know the demand will double, will triple. So that is a multiplication model, right? Let's talk about why we needed these two different models to capture seasonality. Let's see here. First graph, the up one. Well, this demand has very obvious seasonality. Up and down, right? You can think about maybe summer up, winter down, right? Like swimmers glasses, something like that, right? Up and down. Well, that's overall, the fluctuation is very stable. It is very stable, right? So if you have a linear trend as your forecast for average, then you just add something, it's a constant, like 100 above the average for peak season, 100 below the average for the low season, right? Then you have the forecast. That is perfect for additive model. Now come to the second one. I want to ask you, is this also seasonality? This item? Yes, right? Up and down, right? But the question is, can we use the additive model? Use the demand equal to the average plus a constant value. Can we use that? Or minus? Additive model, can we use that? Think about that.
Not on that particular stuff.
Those particular stuff can use. Okay, so basically you mentioned, Patrick, we can't use the additive model. Is that right?
Well, because they're basically throughout time you're looking at a bigger and bigger change from the trend.
That's exactly right. As you mentioned, okay, if you use additive model, which means okay, you have the forecast, right? For example, the first item. Well, what we will do is that, okay, let's say we have a forecast ft equal to 10 plus 2x. Let's say this is model, right? It's an increase trend, right? So basic model is a linear trend model. But for the high season, we say, okay, for the high season, right? And we use what we have, ft plus 100. Low season, we use what we have, ft minus 100. That is additive model. You capture the linear trend, okay? But if the t is the summertime, we plus 100. The winter time, we minus 1. That's additive. Okay, if we want to use the same model to the second one, let's say still the same, ft equal to 10 plus 2x. The linear trend is the same. So the average speaking is still the same trend. But the problem, if we add something at 100, it's too big for the beginning, right? The year one. Why? Because in the year one, the peak probably is only 50 above the average. Maybe it's worked perfect for the second year. But what's happened for the third year? Too small, right? Because the wave become larger and larger. Right? You still have seasonality, but the wave become larger and larger. Then if you use a constant additive model, it's crazy problem. But why the multiplicative model works? Because your forecast ft also increase, right? Your average demand increase. So when you use average demand as a basis to multiply coefficient, say 2, well, automatically when you move forward, okay, your ft increase, right? And you use ft, let's say, high season times 1.5, right? This works. Initially ft is small, and then ft is larger and larger. Then you multiply by coefficients. It can capture this bigger and bigger wave. It's clear? Why it works, right? So so that's the reason, like my previous professor tell me, right? Plot. Before you jump to any model, you think about, oh, that is the first is it has increase trend. You can see from data. Oh, it has very strong seasonality. Yes, well, both these two items, you can see from data. I can guarantee you are smart guys. You can see from the data. But without plotting the historical data, you can't tell which model is perfect. Maybe for most people, like me, assumption like additive model, right? Plus the constants, right? It's pretty easy, right? But you can see the second item, if you use the additive model, that's problem. Only after you plot the data, you know which model should you use, additive or multiplicative model. All right? It's clear for everyone which model to use? Good. Okay. Seasonal relatives. To capture seasonality, we need to calculate seasonal relative for the multiplicative model. Because you need to tell me, okay, is that 1.5 in my example, or 2, or triple, 3, right? Seasonal relative is the seasonal percentage used in the multiplicative seasonal adjusted forecasting model. So to use the seasonal relatives, first we need to de-seasonalize the data. So if we have the historical demand data, we need to first de-seasonalize the data. Means we need to divide each data point by its seasonal relative. For example, right, if you are working in the dealership, selling cars, okay, in your opinion, what is the peak season for car dealers?
It's no, it's by the winter time.
Late fall-ish when they release new models.
Seems you cover all the years.
No, it's
From summer from
it's Thanksgiving to December, October to December. That's the highest.
late fall, yeah, winter. I think so. Basically, it's the second half a year. I think most of us agree with that, right? Several reasons, right? Probably that you have the new model come to the market. For most cars, some cars release the model like 1 year ago, like the beginning of the year. And some other cars really wait very late to release the model. And second is that approach the Christmas and Thanksgiving, especially in the northern area, your older car has some problem or have safety issue that many people want to change, like all-wheel drive, four-wheel drive car. And some other reason, for example, you have some bonus, right? Approach the end of the year. I want some gifts for your kids, right? 16, 18 years old, go to college, you want to give the gifts. So that's the reason. So most likely, okay, in the fall, winter, we have a peak season for the car. So if you look at the car sales, many people will look at, okay, so from January to February until November, December, right? If your car sales is something like that, 100, 120, 150, 160, well, you can't say your performance on November, December is much better than January and February. The reason is that it's not compare apple to apple. Because if you analyze, we have discussed historical data, right? Your November and December sales should be much higher than January and February. How higher is it? You should do the historical analysis. But what we mentioned here, we need to de-seasonalize this data. This is a true historical forecast, this historical demand, right? But by the seasonality, we know we need to divide it by the seasonal relative. If it's seasonal relative for November is 1.5, let's say 1.5 is the seasonal relative for November, then what is the de-seasonalized demand for November in this situation? What is that? 100, right? Because then we use 150 divided by 1.5. The de-seasonalized data or demand is 100. That's what we should do first. Then you can compare apple to apple to January and February. In fact, this salesperson or this dealership doesn't perform very well in November. Well, if you just from the raw sales data, you see, oh, it's pretty good, but we know the seasonality. Like my mom, right, or my parents, they have the bookstore for like 20 years. It's a wholesaler. Well, traditionally, that bookstore, okay, the demand is pretty smooth all of the year, but now we have Amazon, have so many retailer stores. So, well, the bookstore business are not as good as 10 years ago. But, well, I call her recently because it's the beginning of semester. Usually on September and February, that's the beginning semester in China's elementary school and middle school. These 2 months, they have a very busy season. Very busy compared to almost nothing happened on November. Right? So if you think about whether you are doing good business on September, you can't compare this to November. There's no point. Automatically, your September sale much higher in the bookstore than November or December, right? So we have to deseasonalize this data and then compare them. After deseasonalize the data, then we can make a forecast. Maybe linear trend, maybe Liu method, maybe moving average. Then you can make a forecast. You have a forecast model. Finally, when you make a forecast, let's say for next November, right? Make a forecast for next November. The final step, you multiply this seasonal relative, like 1.5. You get the true forecast for next November. Because otherwise, you will under forecast the November, December, this busy season's demand. So that's the general idea how to use the seasonal relatives. Again, we don't have time to cover that in the class, but review the example and then should be fine. Okay. Okay, next we'll talk about, we can say forecast is a lot of contents. If we have to cover each example for each technically, I think we need to spend like 2 months on this chapter. So we have to move forward, but we have office hour, so you are more than welcome to discuss with me during my office hour. Okay. If you have questions for those models we have talked about. Next, we'll talk about the cycles. We have discussed, right? Cycles very similar to the seasonality, but usually we talk about much longer duration or time period. It's happening again and again. Several years, decades, it's happening again and again. To capture the cycles, there's an explanatory approach. So we want to search for some other variables which can be related to what we are interested in. It can be lead to the something happen for the future. The first example is given in this textbook is the house, right? Well, when you talk about the housing demand, or you think about maybe housing price, okay? Usually, the insiders know much better than us, well, for the future housing demand, right? So insider, if I talk about insider, I think I refer to the builder, right? If a builder, they know much better, they say next year, they think, they make the forecast, the housing demand will increase. They will build more new houses, right? Then that's a very good indication about the future house demand or house price for the new constructions. Another example, okay, I want to ask you guys. For example, if we want to forecast the GDP growth, everybody knows GDP, right? GDP growth, okay, economic growth next year. What variable you think can be a good indications for the GDP growth? That's a very broad question for students in school business. When we make a forecast for GDP, there must be a lot of things related to GDP. You can put in the model. Population. Yes, in fact, you are right. But what I want to mention is, in fact, is the trend, like here, right? If you think about the housing price increase, right? Then the increase of the new construction can be an indication of increase of the housing price, right? But for GDP, population definitely very important, right? But I think population trend is more important for the trend for the GDP, right? If you have more population, right? Especially for working age, like 20 to 59, something like that. If that's population percentage increase a lot in the next 10 years, then you will expect GDP growth. That's good. Anything else?
Unemployment rate?
Very good. In fact, unemployment rate is like, it's hard to say the chicken and eggs, which is first, right? You think about it, when GDP is not performing very good, right? During recession, our GDP growth is like negative or like very close to zero. And unemployment rates keep increasing. But on the inverse way, it's the same, right? If the unemployment first decrease, that means like manufacturing, they feel the cold weather. They first lay off people. Then you can know that, okay, the GDP growth in the next year can't be very good. That's a very good indication. Anything else? You think about 2008. I know you guys pretty young in 2008. Probably only play the PlayStation or Xbox. Don't worry about the recession in 2008 or 2009. But well, you must experience 2008, 2009 recession. What's happened before the recession? There any indication?
Housing crash.
Housing crash. In fact, I would say housing crash after recession. But one thing really crashed before the recession.
The banks.
The banks, yeah, very close. What markets crashed before the recession?
MBS.
Stock markets, right? Stock market crash. So I still remember that at that time I was a PhD student in Purdue. While I didn't have any money. I was so poor, so I don't have any money put in my the stock market. But it's very exciting for me to look at the index every day, Dow Jones 2008, because every day it's just up and down. But for several months in 2008, it's like crashed 30%. It's crashed 30%. Citibank, Bank of America, this big name, their stock price is $1 per share. Actually, invest all the money I have, only like a couple $1,000, but I still will earn lots if I invest that money to Citibank and the Bank of America. But 2008, it's before the recession. It's really before the recession, 2008. So 2009, okay, we can see the GDP effect, and then later, as you mentioned, housing crash, right? Housing price reached the peak time on 2007, but 2008 is no crash. It's like stable, right? But because the buying power is decreasing, but the people don't have the motivation to sell their house, right? You think okay, but 2008 and 2009 the recession happened, layoff happened, okay, then crash. But stock markets is a very good indication for the GDP, for the economy, because people in the stock markets, the bankers, they know better about future economy than other people, other industry, most likely. Right? So if you want to make the forecast, that can be a very good indication. Right? So that's what we want to learn, right? To make the forecast of cycle, which is very hard. It's very hard, but there's still something we can use if you study very hard on what are the variables related to the things you want to forecast. Well, we'll talk about another technique. It's called associative forecast technique. It's based on the development of an equation that summarize the effects of predictor variables. Well, if you want to forecast something, well, we want to find something related to that. Like GDP, we'll talk about, even that it's about cycle, but the same thing here, the associative forecast technique. For example, home value. Okay. Home value is related to property size, location, number of bedroom, number of bathroom. First, I want to ask you guys, okay, it has mentioned 4 factors for the house price. Property size, location, number of bedroom, and the number of bathroom. Do you think there's any factor missing here for the housing price? There must be lots of factors missing, but in your opinion, some important factor come to your mind is missing.
Construction year.
Construction year, very good, right? What is a new house or old house? Same location, 1950. Not in North Carolina, but if you go Boston area, so many houses built before the World War One. You don't know World War One when it happened, but 100 years ago, basically speaking, more than 100 years ago. Right? North Carolina, wow, a lot of new construction, but still there's some house like 1916, something like that. Anything else you think is good forecasting for the housing price?
Interest rates, maybe.
Interest rates.
Yeah.
Online loan.
That's a very good point. I didn't think about it. That's right. That's right. In fact, overall, right? So not for the particular house, but overall, like for the whole nation, if your interest rate is pretty high, it will demotivate the buyer's interest to buy a house. Very good. Then probably as a seller, you have to lower down your listing price a little bit. Very good. Anything else?
Materials, like a brick house is more expensive than maybe like.
Very good, right? It's related to the year of construction, right? Because with the new technology, but for the same year, right? Use the brick, use the like wood or plastic, it's totally different. But pay attention to that. I live in a community where I have a labor, right? They have a corner house. Location is pretty bad. It's in the corner, but they have brick. So they list the house for like 2 years, for like 400. They initially list about $500,000. While the decreased price until now is like decreased $50,000, $445 something like that $1,000. But still, it's still in the market. So you like brick house, you like the high level right houses, but the problem when you go to the markets, especially with youngsters, right, many of you don't care about whether brick or not, right? And then this house can be a problem right, to sell. But you know, for the people with age, they prefer brick house. They strongly prefer. Like my parents, they ask me, okay, do you buy a brick house or just wood? I say, well, in US, most houses are built by wood. I say, oh, it's not stable. Earthquake happens. Something. Okay, we don't worry too much about that, especially in this area. But we know that brick house is more stable and it's warm in the winter, cool in the summer. I know that, but the price is a huge difference. Right? It's not worth it, in my opinion, to do that. So pay attention. Something else you haven't mentioned, I want to mention is community. But it's related to location, but it's not exact. For example, the same zip code, right? Or even that's the two blocks away. Well, you can see a little bit different, but mostly it's like the community, right? While some communities are gated community, like some communities like have HOA. Some people don't like HOA. I choose don't say HOA, right? Well, some other communities like a mobile house. Well, that's just not very high level. But apartments, well, the same location, some apartments or complex, well, the price is totally different. Right? So there's so many things related to the house price. Then, how do you make a forecast? You put these factors into a model, like linear regression model. You think about it, right? So we can build a model. I hope in statistics class you have learned that. But if you're not, that's also fine. Right? So your forecast is your price, okay? Your house price, Y. You can add A plus B1x1 plus B2x2 plus B3x3 plus B4x4. If you test the model is from historical demand, the plus data is the linear trend, that is, you can use that. For example, x1 can be the size, x2 is location. We'll talk about how to quantify the location. That's kind of the hard part. Number of bathrooms. Okay, so that is right. Then you can add some factor we mentioned, right? It's like community, like how do you say the material, like the year to build a house. You just put them in the model. Well, have you learned the multiple linear regression model? This one in the statistics class?
We do simple.
Or you just do the simple? Okay. Have you guys learned that? Multiple like this one? No?
Stats 2 is only simple.
Oh, only simple. Okay. Well, but it's also very simple to extend the simple regression to this one. Right? At least for Excel, you just put them in. You can solve it automatically. So that's the basic idea. You add the factor you think is related. Those you think, you test from plots, right? Historic plot is related. And then you can get some model. This is a social model, right? This is just linear regression. It can be quadratic or exponential. That's general idea. It can be any model or any function. So talk about location. Well, it's really hard to quantify location, right? Do you have any idea if we want to put the location in this model? We know that without a number, how can we put in the model? You can't say this location is in zip code 28372, right? This is not the number in the model. How can we quantify the locations factor in our model? Any idea? This is the brainstorm question. You want many forecasting, many things, you have to consider location, right? Well, but if you want to use any model, you have to give a number of this location. You can't say important or good location or bad location. Well, then you can't use the model to make the forecast, right? Estimates. How can we quantify the location factor?
Rank it, maybe?
Yeah,
Some sort of scale.
that's right. Very good, right? Very simple way. So, for example, you give 1 to 10, right? You give it's not so accurate, but it's still much better than like just say good or bad, right? So you give 1 to 10 and you rank them. Maybe not you do some survey, you say, okay, let's say this location, you rank that. Or, for example, if you think this location is highly related to like income level, then you can search for like this zip code, median income, then you can give this location. Or this location important thing for location is close to the interstate, then you can capture the distance between this location to the interstate. Then you can rank them. But there are so many ways. You can do the survey, you can do some other related calculation. Then you can rank, give it the scale of the location, 10 to 1. Then you can put in them. That's very simple way. There's some other complex way, but the idea is the same, right? Number of bedroom, number of bathroom, that you can put in the model. It's very good. One thing about the house is that, in your opinion, because youngsters, your generation, the trend change. Your preference about place to live is very different with the people like 30 years older than you. Yeah. So in your opinion, when you select a home or house, okay, or not even a house, it's just maybe some condo, right? Which factor you think is most important for you? Location.
Yeah.
Same?
Yep.
Location. That's the investments for the real estate. That's very important. Always remember location. If you want to invest a home, house, location definitely is most important. But to live, that can be different. Like many people, well, they think size is very important. You have family, well, probably not for most of you guys now. But if you have family, that's it. Well, but for me, well, I think, yeah, size, location, bathroom, they all matters. Bathroom, not really. Well, you probably should want to have at least 2, but well, with a family. But well, we purchased a house like almost 3 years ago. Well, this house it's not big, like less than 3,000. So it's not big house, but it has 5 bathrooms. We only have 3 people: my daughter, my wife, and me. So every half a month, it's my job to clean all 5 bathrooms. So that I find this has become a burden to me, right? So, well, your daughter can use any bathroom if she wants, so you still have to clean. Even if nobody uses that, you want to clean that, right? If guests come to the home. But I think, okay, we don't need 5 bathrooms. But the problem, yeah, but probably it's very good to resell them, right? Because people think this is very important. You have 5 bathrooms, right? But for me, it's just a burden, right? Well, I think I still miss the day when I live in China with my parents. We only have 2 bathrooms, and it's also my job to clean them, so that's good, right? But 5 bathrooms, right? To clean them, it can be a problem. But bathroom, I think, is very important. I think the bathroom is very important. Well, because if you have big family, you want to have privacy, right? Well, one thing we didn't mention is that structure, right? 1 floor house versus 2 floor house with house with basement definitely also affects the housing price, right? Right. Many people prefer at least 2 floors. Then you have privacy. Live where you don't want to live the same floor with your parents. Many of you, right? As your age, right? So maybe I live in the second, you live in the first. But like for the older people, many people prefer only have the 1 floor. You know, right?
Stairs.
Yeah. Yeah. So it's kind of have a problem, right? Climb down, up and down. Okay, another question for you guys. It's not related to the forecast, about your preference of the house. Do you prefer to live in the suburban or live in the close to the downtown area or even rural place? Rural?
Middle of nowhere.
Downtown?
Suburb.
Suburban? Downtown? Downtown?
Middle of nowhere.
Middle of nowhere.
Middle of nowhere?
Yeah.
Like,
Or raise your hand if you want to live in the rural area. 1, 2,
No.
and kind of rural.
I hate neighbors.
Middle of nowhere. Not middle of nowhere. I mean just rural, small town.
No.
No. Raise your hand if you want to live in the suburban. Oh,
Why?
okay. A lot of people. Raise your hand if you want to live in the downtown, close to downtown area.
It depends on downtown.
Depends on downtown. You mean Detroit downtown? No, yeah. I know.
I'm like,
You mean Pembroke downtown is still belong to the rural area.
that is not a downtown.
Yeah, I know.
That's a 2-minute walk.
Or maybe just city life or village life, right? Pembroke downtown is still close to the city life for sure.
But 20 miles per hour here and here, it's not
Yeah,
quite
exactly.
downtown.
Yeah, but you can see
Like
here.
Amazon.
I can see that
Alaska.
many people prefer to live in close to downtown or suburban. Well, that's a trend change. If you, I heard of NPR is report several times say nowadays the youngsters like your age, people try to move back to the city. But in the past 20, 30 years, people go out to the rural area to settle down, suburban, for example, far away from city. But now younger generation, many people, I don't know if it was area is different, right? Try to move to the city and want to have the walking accessible grocery store, bars, restaurant. So basically they think, okay, we don't have to use car every day. Why we need to use, here you definitely have to, right? You can only walk to the full Lion Plaza, whatever you have, right? Well, but that's the trend. I'm not sure what is true or not, but it's reported that's way. I think there are several reasons, because first, to buy a single family house in suburban, it's expensive, right? You live in the downtown or close to city area, it can be cheaper. You think about that, especially if you don't have to buy a car, that is even cheaper, right? So that can be a reason why that's trying to happen. Another reason is that maybe it's like cycle. I think about that. Like in US, we have this, the trend we move from big city to suburban to rural place, enjoying the privacy for the last 30 years. Then people grow up from this environment, some people, right? Maybe they feel tedious, right, boring. They want to try something new than city life. So that's the reason it can change. It can change again after 20 years or even 10 years later. Say, I don't like big city. I want to move to the suburban. So it's changing. But I just want to mention this because it's a trend change. So when we make focus, also we should capture, right, by age, by your preference, or your education background. Right, it's totally different. For me, I still think I'm a city guy. You want to live in the rural place for more than 10 years. But every time I went back to China, my hometown is a big city with 10 million population, right? I went to China like 3 days, well, gets used to life. But the first day still has some like culture shock. Even when you come back to hometown, you didn't get used to that, right? So why people cross the streets without paying attention to the traffic lights, right? Why the driver are so rude? Why they just beep you every time in the streets are so noisy, right? I complain a lot, but I enjoy the accessibility, right? To go to the restaurant, to go to different facilities, to see the movie theaters very easily, or to hang out with friends. But on the other hand, I realized that especially for my daughter, she really like this place. We live in Fayetteville. It's still, I can't say it's even suburb. I still think it's rural, right? Compared to big city. I think it's good for my daughter, right, to enjoy. My wife, she really want to live in a single family house. Every time she come back to China, she a little bit painful for her. She complain a lot. Her home will only have like 1 bathroom, right? She complain a lot. We have 1 bathroom. We have 5 bathrooms. I clean them. So, well, at least you don't have to clean this only 1 bathroom. Her parents will do that. But yeah, maybe that's the reason I kind of accept. Because my home, right? My parents, they have 3 bedrooms, 2 bathrooms. So it's okay to live in that home. But well, when you choose a life to spend, I think you should be very careful. When you graduate, when you come to big city or small town, it's a big choice for you. It's totally different. I can tell you, it's still. I try to adjust myself to this rural style for the 10 years. Still very hard. Nothing to do because in the evening, right? In the evening, well, I can't find anything to do. Frankly speaking, I can't find anything to do. I'm not a single man. I don't want to go to bar. That's when I was in China. I didn't go to bar. But I can find a lot of still hang out with my friend. I don't need to go to bar. But here, except you go to bar. As if for me, I don't see many places I can go for the evening. Maybe to see a movie. That's possible. So you want to choose the lifestyle you want to do. Then it's very important. Maybe after 1 year you graduate. Well, your location, like we mentioned, is very important. But not just for your job. Some job become very good, but in some place you don't like. Like you don't like big city. This job in the Manhattan. Oh, you have to bear that. I drive in Manhattan several times. It's just crazy. You drive in Manhattan, you drive in some developing country, it's the same thing. Well, it has nothing to do with, okay, what is in the New York or United States. I think if you live in big city, it's the same all over the board. Right? I drive in Madrid. I drive in Tokyo. I drive in New York City. It's the same. You can't expect people so polite. If they live in Manhattan, you can't be polite. You can't get into the bus. You're polite, okay, you go first. You're first and you're last. Wait for the second. Subway is the same. So you choose a place to live, to work, to study. Then it will affect your life. So that's I want you to pay attention when you do the job hunting first. Okay, that's the end of today's class. We'll see you guys on Friday, and then we'll finish chapter 3 Friday.
Yeah, you don't have to pay now. I just had the money and I know I wanted it. Huh? Not often.